Newton's first law of motion, or commonly called the law of inertia. So, Newton's first law of motion says that an object at rest, like the soccer ball, is going to remain at rest. Of course it is. No magic. Unless acted on by an unbalanced force. So the unbalanced force that we're talking about here is this kick. This kick gives it an unbalanced force to cause it to move. An object in motion, so the soccer ball is already in the air, it's already in motion, will continue with a constant speed and direction unless acted on by an unbalanced force. So in this case, that unbalanced force is the net catching the ball and causing it to stop. But a lot of times in physics scenarios, the unbalanced force may involve gravity because gravity makes the soccer ball fall back down to the ground and that changes the speed and the direction. But we're going to talk about that later, so don't worry. The main thing for Newton's first law of motion is just knowing that if balanced forces are acting on this moving object, then the object will just continue to move with a constant velocity. So that means a constant speed in a straight line. And on the other hand, if an object is at rest, then it will stay at rest. But if an unbalanced force, if unbalanced forces are applied, then the object may change speed and or direction. So remember, that would be acceleration. Changing speed, that's acceleration. So it could be an increase or a decrease in speed, or simply a change in direction. Maybe it's going to the left or to the right. So any kind of change in motion is due to unbalanced forces. All right, let's talk about this word inertia. So inertia measures the tendency of an object to resist changes in motion. So if it's sitting, the object wants to keep sitting. It doesn't want to change its motion. It's resisting. It wants to keep sitting. If a ball is rolling across the table, the ball wants to continue rolling across the table. It doesn't want to change its motion. It doesn't want to stop or change direction. It wants to just keep doing exactly what it's doing. So this is all about objects continuing to do whatever they're already doing. If it's sitting, they keep sitting. If it's moving, they keep moving exactly how they were moving. So Galileo actually came up with the idea of inertia. He noticed that objects do not want their motion to change. He also noticed that mass measures how much inertia an object has. So the more mass an object has, the more inertia. So if you compare a pencil to an elephant, obviously an elephant has more mass, so it's also going to have more inertia. Think of it this way. Inertia is the tendency of an object to resist changing in motion. A little pencil doesn't really do that much resisting. You can definitely push a pencil with your hand easily. So it doesn't have a lot of inertia. However, an elephant, if you try to push an elephant with your hand, it's definitely going to resist that change in motion. Because it has so much mass, that means it has so much inertia that the elephant's not going to move just because your little hand starts pushing on it. If you would like to see a demonstration for inertia, you could try this at home. But if you get a cup, an index card, a piece of paper, a piece of cardboard, anything like that, put it on top of the cup, and then you put a coin at the top. So it's sitting there, right? We're going to study the inertia of that coin. So the coin is just sitting there, it's not moving. But suddenly, when you take that cardboard and you flick it or you pull it out really quick, the coin falls into the glass. This is because the inertia of the coin maintains its state at rest, and it falls to the glass due to gravity. So if it wasn't due to gravity, the coin would just sit there. But the coin does have inertia, and it does remain in that place, and whenever you take away the card or the index card, it does fall due to gravity. Another example. So as you drive down the road, and imagine someone pulls out in front of you. You have to slam on your brakes, right? Or at least press your brakes pretty hard so that way you don't end up bumping their car with yours. As you pull forward, whatever's in your passenger seat is definitely going to be flying forward, right? You've all seen it. Also, whenever you're a kid, I'm sure everyone has experienced where your mom's driving, maybe she looks out the window, looks forward, and she's like, oh no, someone pulled out in front of me. So she slams on her brake and she automatically throws her hand across your shoulders as if her hand is going to be better than your seatbelt, right? It's just a natural reaction. Don't worry, I think all moms do it. But that's because the car is slowing down because she's pressed the brakes. However, our bodies inside of that car want to keep going. Our bodies have this inertia where we want to keep moving however we were moving. If we were moving fast, that's why that seatbelt jerks really quick, it locks into place, and then you can't go forward. It can hurt a little bit the faster you're going, but if you're going slow, your body doesn't really have that much inertia. It's not really moving that fast. So if you start slowing down, your body doesn't really lunge forward as much as if you were on the interstate having to put on your brakes. Your body's definitely going to go forward just a little bit. So again, cars are a big example for inertia. Don't let this scenario, this animation be you. Definitely wear your seatbelts. So because of inertia, objects, including yourself, resist changes in motion. When a car is going 80 kilometers per hour, 60 miles per hour, is stopped by a brick wall, your body keeps moving at that 80 miles per hour. 80 kilometers per hour, whatever it is. So that's why you want to have that seatbelt on, so that way it helps you to not have that happen to you. All right, if you have any more questions about Newton's first law of motion or inertia, definitely leave a comment. Thanks for watching.